I am connected to an internal network. Any communication that I am having within a network is completely secure. I do not have to worry that my privacy is at risk. Is that really true? Is our internal network really secure? How does it even work? Well, I'm here to discuss about the protocol that is responsible within a communication within the network. That is Address Resolution Protocol, ARP. Its working, the possible attacks, and the solutions to it. Firstly, how does an ARP really work? Let's briefly go through the process of working of ARP. Let's consider I need to deliver a letter within my neighborhood. I know the street address, the phone number, the name I have to deliver to, but not really the house number. How do I do it? That is where ARP comes into picture. Consider PC1 has to communicate to PC5. The IP address acts as the street address of the letter where I have to deliver to, and the house number acts as the hard-coded MAC address to every PC. Say now PC1 has to communicate with O.1 IP to PC5 with O.5. Now, first it sends a broadcast message to everyone saying, I know the IP, this is the IP, but whoever it belongs to, can you please give me the MAC address so that I can communicate? Now, this broadcast goes to PC2. It is not really the IP, so it rejects and drops the packet. Similarly, repeats to PC3 and PC4. But PC5 gets to know that it is its IP and in turn gives back the hard-coded MAC address. Now, every PC in an ARP protocol stores a table called as ARP table where the corresponding IP address and its MAC address is stored in the table. Now we know the IP, the MAC is given with PC5 and the table is updated. Next time PC1 has to communicate, it doesn't really have to broadcast again. It can directly send through the ARP table that it has a MAC address and the corresponding IP address to it. Do you think that this communication within a network is really safe? Are there no attacks really happening here? Well, there are many attacks this address resolution protocol is prone to. Spoofing, poisoning, and some really help in moving on to the higher layer attacks like MITM, man in the middle attack, denial of service, session hijacking, and many more. Let's just quickly go through one of the famous ARP attacks. That is ARP spoofing. Now let's consider the victim has to communicate to the default router, which goes to the outside world. And now me as an attacker want to sniff this traffic. So what do? I place myself within the network and I take the place of the default router and say that the default router's IP address is my IP address, and I send a fake response to the victim saying, hey, my IP address is that of the default router, and then the MAC address is that of my PC. But the victim thinks that the actual communication is coming from the default router and updates his ARP table with the default router's IP, but the attacker's MAC address. Now it sends a reply to the attacker thinking it is sending a reply to the default router. Now me as an attacker, I'm getting the entire traffic that was actually intended to be sent to the default router. I'm able to sniff the traffic, but I do not really want anybody to know that I'm sniffing the traffic. How do I do this? So I set up IP forwarding saying anything that comes from the victim to the default router, please forward it to the actual default router. So nobody is actually knowing that I'm sniffing the traffic, but the communication is happening silently. This is one of the major attacks. Now, what are the possible solutions to these ARP attacks? We have ARP Watch. So, what ARP Watch does is it notes down, it maintains a database of all the MAC addresses and the IP addresses of the entire communication that is happening within a network. But the ARP Watch won't really prevent from the attacks. It just keeps the data. The next one solution that is there is port security. So in port security, I say that in this switch, this port has to connect to this particular MAC address itself. But this is not really scalable and always depends on the static MAC assignment. The next two, that is firewall and ARP guard, works a little similar. Instead of maintaining the database as an ARP watch, this monitors the entire network, the traffic that is going on, and any suspicious traffic that it finds in terms of ARP response and requests, it sends an alert. But there are a lot of possibility that false positives or negatives can happen here. And the last one is static ARP, where I say that I manually assign that this IP address has to be linked with this particular MAC address itself. Well, we already know that this is manual and it can be only changed manually by the system admin. In this research that I have done, I have developed a unique solution in order to protect from ARP attacks. And the method that I am using is to use secure key exchanges and to maintain a centralized server, and the communication between the ARP response and replies that are happening will be through the key exchanges. So here what happens, this is called as an SARP. Every time a host joins the domain or within a network, it generates a certificate, and along with it, its IP and MAC address, it sends its certificate to the centralized server, which is acting as a repo here. And every communication, as the centralized server already has the certificate, IP, and MAC of the hosts, any communication happens through the key exchanges here. I'll go to the specifics further. Now, how are the two ways the IP is assigned? One is statically assigned IP, and the other one is dynamically assigned IP. So, in my research, let's see how the statically assigned IP works. Let's say we have host H1, host HK, and a centralized server, which maintains all the certificates. Now, when host H1 and HK joins the domain, it generates a certificate with its public and private key pair and puts its IP and MAC address and sends it to the centralized server, which is acting as a repo. Now, let's say that H1 wants to communicate to HK. Also, one thing is that even the centralized server initially sends, for all the hosts that is joined, it sends its certificate, that is the public key, to all the new hosts that is joined. Now let's say H1 has to communicate to HK. Now it has to broadcast this message, that is ARP request, as usual how it happens. But this time, it sends a signed ARP request to HK through its private key. And now HK has to verify the signature, but it doesn't really have the public key of H1. So it sends a signed request to centralized server saying, hey, can you please provide me the public key of H1 because I really got an ARP request from it. Now the centralized server verifies signature of HK, checks in the repo if there is public key of H1, and if so, sends a signed reply of public key of H1 to HK. Now HK verifies the signature of centralized server, gets the public key of H1, and verifies the signature of H1 and sends a signed ARP reply. Now H1 similarly doesn't have the public key of HK. The process repeats, sends a request to the centralized server verifies the signature and gives back the public key. Now HK verifies. If at all it is verified, now it is updated to its ARP table. But during any of this process, if the signature verification fails, or if the centralized server is not really able to find the certificate of the hosts, the app request or packet is immediately dropped, thinking it might be a suspicious or someone trying to spoof or sniff the traffic. Now, this is how it works in statically assigned. How does it work in DHCP assigned? Let's say host H1 has joined the domain again. Now it is generated. Now what it does, it generates a certificate with an empty IP table and MAC address and sends it to store it in the centralized server. Now H1 needs an IP assigned. So it requests the DHCP server, hey, can you please give me the IP? I just joined the domain. But now DHCP server doesn't really know if it's a valid host. So now it sends a request to the centralized server, signed request saying, hey, I got a request to assign the IP, and this is the IP I'm planning to assign. Can you please check if this host is actually the valid host joined the domain? Centralized server verifies the signature of DHCP and now checks if it is there in the repo that H1 is present. If at all it is present, updates the IP where there was an empty table that was there in IP column, and then says, acknowledges it, saying, hey, yes, this is a valid host and you can assign the IP. Now the DHCP server further goes and assigns the IP to the H1. And the further process is similar to how the statically assigned IP process works. So this is a small solution that I developed to have a key exchanged ARP, safe ARP communication to happen. Well, the main conclusion from this presentation is that any communication within a network does not mean a secure communication. So please be aware of it. And be always wary of who you talk to, even if it is within a network. And please secure your ARP. Thank you.